Good morning and welcome to part 2 of Online Math Thinking Fundamentals, the series where we learn how to learn like a mathematician. Today's topic is relationships. Now, when it comes to doing math, we cannot consider only the numbers themselves. That is obviously an important building block, but by themselves they do nothing until we connect them. Right? It is the connection, the relationship, that is where the true meanings come out in mathematics. So let's start by considering one of the simplest relationship. Equals. One number is the same as the other number. I'll make that the center of my idea web. And as seemingly simple and basic as this is, you got to understand, thinking back to your own math class experience, this clearly is a big deal. You use it quite a lot. Because typically, the numbers you're wanting to make equal do not look the same, right? We are talking about 4 is equal to not just writing another 4, but writing it in some other method, right? And that is where that relationship now has value. It shows two things that look seemingly different are in fact the same. That's a big idea, right? I'm trying to think of another analogy, but it's if you were to look out in the parking lot and you see all these different vehicles. Oh, there's a car, there's a truck, there's a Toyota, there's a Honda, there's a Ford, right? You can notice all of these differences. They all look different. But you can also look at what is the same. They all have 4 wheels. They all have an internal combustion engine. They are all means of transportation, right? And so in that way, the Toyota car is the same as the Ford truck in some respects. I understand there are differences. Just like there are differences, we can look at the screen, over there, right? Look right there. 4 is not written the same as 2 plus 2. But they both equal. They both serve the same purpose. Now, in addition to equality, we could go into the realm of geometry and talk about congruency, right? Where things have the same size and shape rather than just amount, okay? That's another very related idea. We could also go in another direction and instead use greater than or less than or greater than or equal to or less than or equal to. Okay? And we can make funny cat faces online, but we can also use these to compare, once again. It seems like all of these, maybe I should make a broader category here, that all of this are comparisons. I'm going to have another category in a moment. Now my idea web has turned into half Venn diagram, but I think you can understand where the greater than and less than symbols come into play. Let's face it, not every number is equal to itself. If all the numbers were the same, well, math would be pretty boring, actually. And life would be really, in a way, simpler, but also greatly boring. You couldn't ever have more breakfast. That would be probably the saddest thing, actually, right there. So in addition to the comparisons, I'd like to call another category here. We'll just make another gigantic circle. I'm going to call this one the combinations. Right there. Now, if I were to ask you, what are some ways you can combine numbers? The first ones that come to mind, ideally, how can I put 2 numbers together in such a way? Now we're getting into our basic operations: add, subtract, multiply, divide, right? Those guys. These are ways that 2 numbers can combine together, ideally to create a new number. That's usually the end result. But they do hold meaning right there as that combination, as those 2 separate numbers in a new relationship, right? Go back up to the 4 equals 2 plus 2. The 2 and the 2 are forming a partnership, right? They are becoming one, right? It's a bad analogy, but it's like, they're marching down the aisle on their wedding day, right? They are becoming one number. And that addition, that relationship is an equal partner relationship, right? It has a special property that subtraction does not, right? We give that property a special name if we wanted to, and we could say, here's where the Venn diagramming comes in, right? These guys are, remember the fancy term, commutative, right? The order doesn't matter, right? We can swap them around one in front of the other and we still get the same result, whereas subtraction and division do not do that. And so what we have here, and let me just fill out the thing here. We also have, we could have exponents, x to the y, right? That's another combination, a way you can arrange numbers. What else we got? Oh, here's another fancy one, right? We could, of course, list numbers and if we list them in a very particular way, and you put these fancy brackets around it, now we've got another name for those, and we call that a matrix, right? And that is a fancy list of lists, but now the listing is itself a combination. I guess more permutation to be technical here, right? Order matters there, but it is a relationship between all of those elements. They now serve a purpose in the location that they are, right? And so this is, I guess, the matrix would not be commutative. You cannot just switch the order around and get the same result. It would be a new separate list, okay? And this means sometimes our order matters, sometimes our order doesn't. The arrangement can be an important aspect of the relationship itself. Sometimes, in the case of the matrix, it's the only relationship. There is no operation. There is nothing saying we're going to take these numbers and they're all going to get added and then these ones are going to get subtracted. That's not going on. It could. That is one thing you could end up doing with the matrix. By itself, it's already in a relationship. Writing two numbers next to each other, already in a relationship. What if I take the 2's from before and I write a 2 and immediately follow it with another 2? What happens? Is that 4? Is that the same thing? Not at all. That is not even 2 times 2. Often, when you get into algebra, we typically stick things right next to each other when we want them to multiply, right? But if you just put two regular numbers, regular numerals written there, now we're dealing with place value, right? The 2 in front somehow becomes more powerful than it once was by nature of where it is in the order. That's a new relationship. Sticking these 2's, the closer they are together, suddenly now it becomes 22, right? Way more than a single 2 or even the 2 added together, multiplied. In fact, 2 is kind of that unique element there where add, multiply, or even exponent, you get the same result. 2 to the 2 is also 4. But if you stick them together now, you get 22, something very different. Okay, so that relationship creates a new number, a new value. And this is where all the math happens. The study of these relationships, using these relationships to combine numbers, to compare numbers to each other, is where all the math actually happens. All the numbers themselves, yes, those are the building blocks, those are the basic elements that we'll be using. But the math properties, right? We could talk about a number having properties. We did that last time. A number could be even or odd. It can be a prime. It can be a factor of this. None of those properties make any sense by themselves. You call 4 even. That tells you absolutely nothing unless you know that evenness is a relationship among other numbers. It means 4 can be divided by 2. There's an operation. That is a relationship. The rest of your mathematics career is going to be about learning new relationships. How does one subject, topic, number connect to another? How do they relate to each other? What is the combination here? What is the order I need to do things in? Order of operations comes into play here, and it will continue to come into play. Can't ever forget that. Layer upon layer, building and building stronger relationships, just like humans actually do, right? First you meet, and you become friends, and then you go dating, and you get engaged, right? All that, layer upon layer, more and more complex relationships as you find new avenues, new ways to compare, contrast, and combine. That is how math gets used in the everyday life, right? You never just use math as a list of numbers, right? We use them to highlight the relationships, whether it's statistical analysis or doing commerce and economics and something like that. Mathematics used in the real life, engineering, right? We want to know this number doesn't hold much meaning. Oh, it has this car, once again, right? 200 horsepower. Great. Is that a lot? Right? To use the Doctor Who meme. Is 4 a lot? Depends on the context, right? 4 what? What's the relationship? 4 horsepower sounds great if the thing you're comparing it to is a horse. It's like 4 times as many horses. That sounds pretty nice to me, right? If you're a guy back in the 1800s that only had 1 horse, right? Suddenly I have one device that can do 4 horses worth of work. But nowadays, compared to a lot of cars, 4 horsepower is getting kind of pathetic, right? That's not very lot. And so it's the relationship between that 4 and the 200 versus the 1. That is where the analysis comes into play. All right. I think I've pretty much exhausted this topic in isolation. This will be brought up again and again moving forward throughout this series, and again, just math everywhere. Think about it in terms of relationships. That is my invitation to you. That is our mental exercise for the day. How can I think about math and everything as a relationship? Oh, when I turn on my light, what is the relationship happening here? Right? It's a very, very romantic kind of idea. Your English teachers will thank you. But for now, we're going to leave the video as it is. So thank you for watching. So long, farewell, enjoy the rest of your day.